We are told a scientist is studying a population of mice on an island. The number of mice n in the population t months after the start of the study is modeled by the equation n equals 900 over 3 plus 7e to the power of minus 0.25 times t, where t is a real number and t is greater than or equal to 0. Part A has asked us to find the number of mice in the population at the start of the study for 1 mark. Okay, so I'm just going to highlight some key parts. Okay, so the number of mice is n. T months is the time after the start of the study. Okay, I'm also going to highlight the equation which is being used to model it, and I'm going to highlight that we need to find the number of mice in the population at the start of the study. Okay, when you're told at the start of something, this usually means t equals, actually always means that t equals 0. So what we need to do is we need to plug in t equals 0 for our equation. Okay, so we're going to say n at start, okay, equals 900 over 3 plus 7 e to the minus 0.25 times 0. Okay, this equals 900 over, so e to the minus 0.25 times 0. So it's going to be e to the power of 0, which is going to be 1. So it's going to be 3 plus 7 times 1, which is just going to be 10. So 10, and then this equals 90. You get 1 mark for this question, and that 1 mark comes from getting a starting population of 90. Part B says, show that the rate of growth dm by dt is given by dm by dt equals n times 300 minus n all over 1200 for 4 marks. Okay, so what we're going to do is I'm first going to rewrite n without the fraction components. I'm going to say that n equals 900 times 3 plus 7e to the minus 0.25t, and then all of this to the power of minus 1. Okay, the next step is I'm going to use the chain rule. So the chain rule says if you have y equals a function of another function of t, so y say just f gt like this, what this means is that you can rewrite y as y equals a function of u, and then you can say that u is a function of t, and then in turn dy by dx will equal the derivative of the function of u times the derivative of the function of g, and then what you will end up doing is you will be replacing u with whatever your function of gt was. Okay, so what I'm going to do is I'm going to say n equals 900 u to the minus 1, and I'm going to say u equals 3 plus 7e to the minus 0.25t. Okay, I'm going to say dn by du equals minus 900 times u to the minus 2, that's basic differentiation, and then I'm going to say du by dt equals, so 3 differentiates to 0, and then you have 7e to the minus 0.25t. What you would do is you bring this minus 0.25 in front of the exponent, so you would get minus 0.25 times 7 times e to the minus 0.25t, like that. Okay, so from here what we can say is dn by dt equals, so we have this minus 900, and then because we have 0, minus 0.25, etc., we can cancel this 0, and we're just left with minus 900 times minus 0.25 times the rest. So it's going to be 900 times 0.25 times 7e to the minus 0.25t times u to the minus 2. But we know that u is 3 plus 7e to the minus 0.25t. So this is going to be times 3 plus 7e to the minus 0.25t, all to the power of minus 2, sorry. Okay? Now what I'm going to do is I'm going to replace all the instances of t to write them in terms of n, okay? Because our final differential is given in terms of n. So because we know that n equals 900 over, so I'm just going to actually do that, over 3 plus 7e to the minus 0.25t, okay, we know that 3 plus 7e to the minus 0.25t equals 900 over n, and by extent 7e to the minus 0.25t equals 900 over n minus 3. Okay? From here, what we can do is we can plug in 900 over n into here, and we can plug in 900 over n minus 3 into here. So what we'll end up with is dn by dt equals 900, now 0.25 is 1 over 4, so it's going to be 900 over 4 times 7e to the minus 0.25t. We said that is going to be 900 over n minus 3, and then times, now we have 900 over n to the power of minus 2. But what we can say actually is we can say that this is n over 900 to the power of 2, because the minus will invert the fraction. So we'll just end up with n squared over 900 squared, like that. Okay? From here, what we can do is, because this sort of resembles the 300 minus n form we need, okay, because we've got 900, n, and 3. What I'm going to do is I'm going to take out a factor of 3 over n, okay, so this is going to be 900 over 4 times 3 over n, and then in brackets, it's going to be 300 minus n. And the reason is because the 3 is taken out as a factor, so you have 900 divided by 3, which gets you 300, and then you have minus 3 divided by 3, which gets you minus 1. But since you're dividing by n, you have 1 over n, so you take that out as a factor, but then because you have 1 over 1 over n, which is just n. So that gets us like that, okay? And then this is going to be times n squared over 900 squared, okay? What I'm going to do now is I'm going to start cancelling terms. So this 900 squared and 900 cancel, so all you're left with is 900. This n and this n squared cancel, so all you're left with is n. And then this 3 and this 900 again cancel, so all you're left with is 300. Okay? So, in conclusion, what you'll be left with is this equals n over 300 times 1 over 4 times 300 minus n, and then just to finish it, we can say therefore dn by dt equals n times 300 minus n all over 300 times 4 is 1200, like that. So this question is worth 4 marks. Your first 2 marks come from correctly doing the chain rule to get this line. Your third mark comes from substituting any instance of 7e to the minus 0.25t with this correct form of n, so what we have done up to here. And then your fourth and final mark comes from doing the correct algebra to get the final answer as we have down here. Part C has told us the rate of growth is a maximum after t months. Find, according to the model, the value of t for 4 marks. So when it says anything is a maximum, okay, after t months, what it is looking at is it's looking that dn by dt equals 0, okay? So what we need to do is we need to look at the graph for when dn by dt is 0. So this means we need to look for when n times 300 minus n equals 0, alright? So if I was to draw the graph, okay, which looks something a bit like this. It's a negative quadratic, like that, okay? We say that this is 0 and this is 300. This axis is n and this axis is dn by dt, okay? So just checking it makes sense. When dn by dt is 0, so that means here, n is 0 and then so that's all correct, okay? Now, what we need to look for is when dn by dt is a maximum, and it's a maximum at here, okay? And because this is a parabola, it is symmetric between the two roots, so this is going to be 150, okay? So it means that dn by dt is a maximum at n equals 150. So we can just find that dn by dt is maximum at n equals 150. Alright? From here, what we can do is we can plug in n equals 150 into our equation. Okay, so what we're going to say is 150 equals 900 over 3 plus 7e to the minus 0.25. Now be careful here, we've been told to use capital T, okay? So that's the one I'm going to use. So it's going to be capital T like that, okay? Rearranging this, so this means 3 plus 7e to the minus 0.25 capital T equals 900 over 150, which is 6, so equals 6. Then we have 7e to the minus 0.25 capital T equals 3. E to the minus 0.25 t equals 3 over 7. Minus 0.25 capital T is ln of 3 over 7. Okay, and this means that t equals ln 3 over 7 times minus 4. Okay, so if you were to put this into your calculator, you would get a time frame of that t equals 3.38 etc. months. I'm going to round it to 3.4 months. Okay, so it's just say that therefore t equals 3.4 months, like that. Okay. This question is worth 4 marks. Your first mark comes from showing that n equals 150. Your second mark comes from getting that e to the minus 0.25t equals 3 over 7. Your third and fourth mark comes from doing the correct rearranging, and here you can have either that t equals minus 4 times ln 3 over 7, or that t equals 3.4 months. Either one gets you both of your final marks. We have been told, according to the model, the maximum number of mice on the island is p. Part D has asked us to state the value of p for 1 mark, okay? If you were to look at the graph of this equation, okay, so you were just to plot it or to sketch it, okay, what you would notice is that it increases forever, okay? So I'm just going to draw it, and it goes up something like this, okay? What this means is, it means as the time gets extremely large, the model won't end up reducing, or won't end up decreasing the number of mice. So the number of mice will constantly grow. Sorry, if this is t and this is n. Okay? So when it says, what is a maximum number of mice, okay, what you are able to assume is that this is taken into account as t approaches infinity. Okay? Actually, I'm probably just going to change the colour. So as t is approaching infinity. Okay, so when t approaches infinity, what we can say is that as t approaches infinity, 0.25t also approaches infinity, meaning that minus 0.25t approaches minus infinity, and that e to the minus 0.25t would approach 0. Okay? Because remember, minus infinity, so as the number gets smaller and smaller and smaller and smaller and smaller, it will become 1 over a very, very, very large number. So that's going to be 0. So it's going to approach 0. Okay? From here, what you can say is, this means that p equals 900 over 3 plus 7 times 0, which is 900 over 3, which equals 300. And for this question, you get 1 mark, and that comes from getting 300 as your final answer.